last lesson of the year. Volume of spheres. The quickest lesson we're going to do today. Identify the parts of spheres. You're going to know what a sphere is and what the parts are. You may think of them as globes, but they're spheres. Find the volume of a sphere. Find the volume of a hemisphere. Find the volume of a composite solid that has a sphere attached to it. So, let's hit the ground rolling. That's a sphere. How do you think you would describe a sphere? Yeah, something. If you said it's a set of points in a space, three-dimensional space, that is all equidistant from a given point. So what happens is you have one point here. Say my hand's a point. This is the space around. So if I just took this thing and moved it in every single possible direction around my point, I would eventually draw a sphere. So see, look, it goes around this way, goes around this way, goes around every way. It creates a sphere. So, center. The point, my actual point, where every other point is equidistant from. All right, that's my center. The radius of a sphere is the distance from the center to any other place. So this, when in my little terrible diagram I drew for you before, this little pink pointer guy would be the radius. All right. So from the center to any point that actually makes up the sphere. A chord. If you have your sphere and you just have a piece that goes from one piece to another piece but does not go through the center, that would be your chord. So your chord, there's my radius. My chord is a segment whose endpoints are on the sphere. Chord. And a diameter. Find the last one's diameter. Well, the radius goes from here. But see, I took a second radius and went the other way. This combined thing would be my diameter, just like the diameter in a circle. It goes from one part of the sphere to another part. So it's the chord, but it contains the center. Boom. All right. We got something here called a great circle. Not the Great Pumpkin, Charlie Brown. Great movie. Underrated movie. But a great circle. It is the intersection of a plane and the sphere containing the center. So if I took, say, a sphere or a basketball and I cut it directly across the middle, that circle cross-section area, right over cross-section, would be a great circle. So it's the largest circle cross-section you would get if you cut a sphere. And by cutting it with the great circle, you get yourself a hemisphere. Hemisphere is just half a sphere. All right, we live in the northern hemisphere of Earth. Then the southern hemisphere, places like South America, all right, Australia, they are southern hemisphere. All right, we also live in the western hemisphere, eastern United States, but western hemisphere. Places like, once again, Australia, Africa, Europe, they're in the western hemisphere. All right, so that's hemispheres. That's just half the sphere. You cut it directly in half, one half the other half. How do you find the volume of a sphere? Very difficult mathematical formulas went in defining the volume of a sphere. It is 4/3 pi r cubed, where r is the radius. Now, even though this formula is a little wonky looking, a little weird, what you do know about this formula is it's the easiest one to fill in. All you need to do is the radius, and then you're done. So r is the radius of the sphere. Watch how easy this is. Here's my sphere. Radius is 3 millimeters. So, sphere formula is 4/3 pi r cubed. I take my radius, which is 3 millimeters. I plug it in. So, in your calculator, 4 divided by 3 times pi, 3, the caret button. In case you don't know what a caret looks like, it looks like a triangle with no bottom. And then 3, that raises 3 to the third power. 3 to the third power is not 3 times 3. It's not 9. That's 3 squared. It's 3 times 3 times 3, which is 27. So 27 times 4 divided by 3 is 36 pi. 36 times the pi button is 113.1. So the volume of the, whoa, why does that say cone? The volume of the sphere, what number is this? Number 1 I got to fix already. Is 113 millimeters squared. All right, cubed. Got it? Excellent. Go. Let's see. First one, 4/3 pi r cubed. 4/3 pi 13 cubed. Answer should have been 7,238. That is your diameter. You can't use diameters. You need to use radiuses. So convert the diameter to radius by dividing by 2. 42 divided by 2 is what? 21. So We're going to use the same formula. 4/3 pi, 21 cubed, 38,792. You give it the radius. 4/3 pi, 7 cubed, 1,437. 19 is my diameter, or my radius. Half of 19 is indeed 9.5. 4/3 pi times 9.5 cubed gives you 3,591 as an answer. Feel good? No, you are, because it's very easy. All right, now let's go to some tricky ones. 6, 7, 8, and 9. Now, these are not just spheres. These are part of spheres. So number 6 is how much of a sphere? A hemisphere is half a sphere. Now, the diameter is, so that's half of 4/3 pi r cubed. Half the volume of a whole sphere is half a sphere. Duh, that makes sense, right? 16 centimeters here is my diameter. I want to turn it to radius, so half of 16 is 8. 1/2 of 4/3, which is 4/6 pi 8 cubed, is 1,072 cubic centimeters. How much is this? This is, once again, is a hemisphere, so half of 4/3 pi r cubed, half of 4/3 6 pi 6 cubed. Type in the calculator, 1 divided by 2, times 4 divided by 3, times pi, times 6, caret 3, 452 centimeters. I notice by just changing this from 8 to a 6, it does decrease the answer a bunch. Okay, because 8 cubed is 8 times 8, which is 64, times 8, which is like almost 500. 6 cubed is 6 times 6, which is 36, times another 6, which is like 200. So this is almost twice as much. Got it? That's why this is twice as much. All right, the radius of this solid, this looks like a chunk of circular cheese, a spherical cheese that someone took a little piece out of. Right? That's what it looks like to you? I don't know. So how much is this? Well, let's look. 1, 2, 3. There's 4 pieces. Let's go back to 3rd grade. And one of them's gone, so that means I have 1, 2, 3 out of the 4 left, so I have 3/4 of a sphere. So 3/4 of 4/3 pi r cubed. It says the radius is 150. All right, 150 feet. Oh, since that's 150 feet radius, this distance from here to here, I doubt it's a piece of cheese. That'd be a giant piece of cheese. So maybe it's like an asteroid, or I don't know what it is. So 10,602,875 cubic feet is your answer. All right, you got a little light here. This is a little light you put over some things. All right. Does that look like half a sphere? No. Looks like you have a solid and a solid. So that's actually a quarter times 4/3 pi, 10-inch radius, 10 cubed. 1/3 times 4, so 1/4 times 4/3 is 1/3 pi, 10 cubed, which is 1,047 cubic inches. Are we all good? Almost done. Let's do some composites. Ow, that was the name. Find the volume of the composite solid. So you have a cylinder and you have something out of the cylinder. So volume of the solid equals your volume of your cylinder. That's the big thing. And what's this right here? A hemisphere, half a sphere. So what are you going to do with these two since you're carving the hemisphere out of the sphere? Out of the cone cylinder? Subtraction. It's right there anyway. So the volume of a cylinder minus the volume of a hemisphere is the whole total volume. Volume of a cylinder is pi r squared h. Volume of a hemisphere is 1/2 of 4/3 pi r cubed. What is the radius here? Oh, my radius is missing. That should say 3. Oh, what did I do with my radius? All right, there's a little 3 here. It's on your sheet. I don't know why it's not here. So 1/3 3 squared times the height, which is missing 2, is 5. All right, that's missing from my cylinder for some reason. Minus right here, this has the same radius. The radius for this is 5 as well. 3 as well, sorry. So this should say 3 here, that should say 5 there. Pi, 3 squared times 5 is 45 pi. 1/2 times this is 2/3 pi times 27 is 18 pi. 45 pi minus 18 pi is 27. You just subtract the numbers and keep the pi. 27 pi. You don't really give answers in pi when you're finding volumes. So you do 27 times pi and you get 85 cubic inches, which is your answer. There they came. They came out of nowhere. Oh, there were. All right. You good? All right. Finish. We got 4 problems left. This one. The volume of the hemisphere. 1/2 of 4/3. The radius here is half of 7, which is 3.5. 1/2 of 4/3 pi, 3.5 cubed. Gives you about 26. You have a cylinder right here. The volume of the cylinder is pi r squared h. Once again, the radius is 3.5. Pi 3.5 squared. The height is 5.5. 212. What do you do with these two numbers? You take your cylinder and you subtract out the hemisphere. (212 minus 26). And you get 86. Wait. No, you don't. 212 minus 26. Maybe that's not 26. Uh-oh. I'm going to have to do some math in here. The math here is a little messed up. I got to get back to that. Anyway, next problem, number 12. Problem number 12. 1/2 of 4/3 pi r cubed is the top. 1/3 of 4/3 pi, radius is 10 cubed, is 90, right? All right. Times pi times 3.5 cubed. This was 90. Wait a second. That messes everything up. So this was about 90. 212 minus 9. No, that's not right. 3.5 squared times 5.5 times pi. That's right. 1/3 times, this is where I messed this up. This answer is not 26. It's 1 divided by 2 times 4 divided by 3 times pi times 3.5 up arrow cubed. (42) times 4 divided by 6 times pi. Yeah, this is 90. So this should have been 212 minus 90. And 212 minus 90 is 122. So this answer is 122. I'm sorry, very sorry. 90, 122. I had to go back and do that. All right, so this answer right here, oh, that's where my 90 went. 1 divided by 2 times 4 divided by... Right. I'm going to have to splice this whole thing out. Okay, stop this. Well, actually, I'll keep this going. I'll just splice it up in the same video. I'm just going to start over from here. 1/3 pi r squared cubed. One-third pi times 39 squared Let me just make sure I got this right. we're still going here. That's a big screw up. Oh, it's only 20 minutes. All right. On to example number 10. Now, what we're going to do here is we're going to find the volume of a composite solid. In order to do that, you find the volume of the composite solid containing a cylinder and a... Oh, we got to do this over here. All right, now we're going to move on to example number 10. We're going to find the volume of a composite solid consisting of more than one composite solid. All right, so first thing you do is you want to find the volume of the solid. What two composites do you have here? What two solids that we know how to find the volume of do we know? Do we have? We have the volume of a cylinder, and right here is the volume of a hemisphere. So we know those two volumes. Now, since we're carving the hemisphere out of the cylinder, we are going to use subtraction, okay? So we use the volume of the cylinder minus the volume of a hemisphere. The volume of a cylinder formula is pi r squared times height, and the volume of a hemisphere formula is half of that is a sphere, so it's 1/2 of formula of a sphere, which is 4/3 pi r cubed. Now, first thing you do here is you have your radius. Radius is 3, so we have pi 3 squared times the height, which is 5, minus 1/2 4/3 pi, same radius for the hemisphere, which is 3 cubed. Type this into a calculator. Pi times 9 times 5 is 45 pi. 1/2 of 4/3 is 2/3 pi, times 27 is 18 pi. 45 pi minus 18 pi, well, you subtract the numbers and you keep the pi on it, you get a 27 pi. Only problem is no one really goes about saying, oh, that's 27 pi units volume. Now, you would do this as a regular number, so you do 27 times pi and get 85, about 85. So it's 85 cubic inches. The volume of this pretty much cylinder with the hemisphere carved out is 83 cubic inches. All right, now let's move on to problem number 11 and 12. Now these two problems are very similar, but they're a little bit different. So problem 11 is actually almost identical there. You have a hemisphere carved out of a cylinder. So the volume of this hemisphere is 1/2 that of a cylinder. The radius here is half of 7, which is 3.5. So the volume is 1/2 of 4/3 pi times 3.5 cubed, okay? 1/2 of 4/3 is 2/3 pi times 3.5 cubed, which is approximately 90 cubic units. Volume pi times 3.5 squared times 5.5 is approximately 212 cubic units. Take these two numbers and what do you do with them? You subtract the two because you're carving out, once again, taking that hemisphere out, taking it out of the cylinder. 212 minus 90 gives you approximately 122 cubic units. Ta-da! Right here. Now we have our cylinder, our hemisphere, and we're adding it to the top of the cylinder. So once again, you find the volume of your cylinder, 1/2 of 4/3 pi times 10 cubed, and that gives you 2,094. Volume of my cylinder, no 1/2, it's just pi r squared h. So 10 squared times 16, which is 5,027. And you don't subtract these two because you're adding the hemisphere on top. You add the two together. 5,027, oh, that should say a plus. Plus 2,094, and that gives us the answer. All right. Okay, cut. This one's all messed up. All messed up. I should give like the greatest, most messed up shit here. Arrow. Add 5027 plus 2094. You can tell I never get to this lesson. 7,121. And that's plus and plus. All right. Plus, plus. Good. Now, after you add these two together, what your next step is going to be is to add the sphere and the cylinder. 5,027 plus 2,094 gives you a grand total of 7,121 cubic units. All right, easy as pie. Now let's move on to 13 and 14. As you can notice, these are both very similar problems, pretty much identical. They are hemispheres on top of cones. So, first one, 1/2 of 4/3 pi r cubed. Radius here is 4.9. 1/2 of 4/3 pi, 4.9 cubed, gives you 246. 1/3 pi r squared h. 1/3 pi, 4.9 squared times the height, which is 12.6, 317. You add the two of them together, the two solids, to give you one large composite solid with a volume of 563. All right, and finally, number 14, you have your, let's do hemisphere on bottom, 1/2 of a sphere, 1/2 of 4/3 pi 39 cubed, 124,237. You have a big height here. Your height is, now, it's not 81. It's actually 81 minus 39. Because this is 39, this is 81. So you subtract the two, and that gives you a total height here of 42. All right, so 1/3 pi, still the same radius, 39 squared times your height now, which is 42. All right, 66,897 is the total volume. All right. Add the two volumes together, and you get a grand total of 191,134 cubic units. All right, so that concludes all the volumes that you need to know. We went through all of them. Today was a nice, easy one with sphere. And then the next thing we're going to do is we're just going to review for this with the Kahoot. All right, so till next time, excellent teaching, you guys. Cha-ching.